guys, today we are going to do some review of graphing equations in preparation for a project we're going to do. So the first section here is all linear equations, and I know that you recently reviewed a little bit of that. So as a reminder, you're going to put it into slope-intercept form and then go ahead and graph. So I'm going to have you do those on your own. The next section I wanted to review is absolute value. So absolute value graphs, as a reminder, are going to look like V's. So they could be a right side up V or an upside down V. And the way that we're going to graph them, you have a couple options. You can use the transformation rules to graph them. So for example, we know that this is a shift left 1, and we know that this is a flip to upside down V. So it reflects in the x-axis, and we know that this is a vertical stretch by a factor of 2. So if you remember how to do that, you're more than welcome to do that. If not, you can always make a chart of values that works on any graph ever, if you're not sure how to graph it. So I'm just going to do that for this one. So we have x and we have y. And we're going to go ahead and plug in some points. Now, typically what we plug in are these points. I know there's some debate as to what order we put them in. It doesn't matter. And then we'll see what happens, and we'll see if we need to plug in any more points. So when I put a negative 2 in, negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. 1 times negative 2 is negative 2. I'll do the same thing for negative 1. And that, when I put it the negative 1, negative 1 plus 1 is 0. The absolute value of 0 is 0, and 0 times negative 2 is still 0. When I put a 0 here, this becomes 1. The absolute value of 1 is just 1, and then 1 times negative 2 is negative 2. When I put a 1 in here, 1 plus 1 is 2. The absolute value of 2 is 2. 2 times negative 2 is negative 4. And when I put a 2 in, 2 plus 1 is 3. The absolute value of 3 is 3. 3 times negative 2 is negative 6. All right, so let's see what we have here. When we go ahead and graph this, I'm just going to make it a thicker marker, we're going to use these points. So we have negative 2 comma negative 2. That's going to be there. Negative 1, 0. 0, negative 2. 1, negative 4. And 2, negative 6. So you can see the V here. It goes up here. This is the vertex because it's where it changes direction. So what we could really do, we can tell this is the vertex. There's going to be a mirror right here. We could plot these 2 points on the other side as well. So this is 1, 2 away from the vertex right here. So we go 1, 2 more. This is 1, 2, 3 away from this line. So 1, 2, 3. Okay, so that is what our V is going to look like, and then you're going to use your pencil. I'm going to cheat, and we make our V look something like this. It's going to extend forever it's going to extend forever this way, and also this way. Okay, so as a reminder, that's how you can graph absolute value equations. Go ahead and feel free to pause the video here and do the rest of the absolute value ones, or if you want to keep watching and do the quadratics and then go back, that's fine also. Okay, so we're going to look at number 9 now. This section is all about quadratic functions, which we've done this also, but to review, you can, I don't know what that does. You can make a table of values, but we learned a different way to do it that's a little faster. It will help you find the vertex more easily because sometimes you're not sure where that is. So as a reminder, the first step is to find the axis of symmetry. That's going to be our mirror, right? Because quadratic functions make a U and they're symmetrical. So the first thing we need to do is find the axis of symmetry, and the formula for that is negative b over 2a. So this is in the form, it's in standard form, right? So the standard form of a quadratic function is ax squared plus bx plus c. So if I look at this, I'm looking for b, that's going to be 12, but I have negative b, okay? So that'll be negative 12. And then I have 2a. So a is negative 2. 2 times negative 2 is negative 4. This is going to simplify to 3. So here's what that means. we are going to find their vertex, but we already know that the x value is 3. It's going to be 3 comma something. The other thing we know is that there is a mirror on x equals 3. So you're going to go ahead and draw that. You can do that. And so we know that that's the middle of our parabola. That line isn't really in the parabola, but that's just going to help us determine where points are. Okay, so now we're going to find the y value of our vertex. And remember, the way we do that is we take the 3, we plug it back into this equation, and we get a y value. So if I pop that into my calculator, 3 squared is 9. 9 times negative 2 is negative 18. So this becomes a negative 18. You can pop the whole thing in your calculator if you want. 3 right here gives me a 36. And then minus 20. Negative 18 plus 36 is 18. 18 minus 20 is negative 2. So that means the y value of our vertex is negative 2. So we're going to go ahead and plot that point. 3 comma negative 2 is going to be right here. Okay. The next thing that we did was we found some additional points and we plotted them, and then we found their partners on the other side. We could also, you have a couple options when you're graphing parabolas. If you were to factor this, you could also find where does it hit the x-axis, because the answer, when you find the roots, the answer when you factor it, that's where it hits this. But I can already tell it's not going to, and here's why. There's a negative here, and that means it's an upside down u, which means this is actually the maximum. It's the top point. It's never going to hit this. So if we were to factor this, we'd have to use the quadratic function, and it'd be imaginary. It would be a negative square root. So it would be kind of like when we did the discriminant and we said how many solutions are there. The answer is none. They're just imaginary, which you'll do in Algebra 2. So instead, I'm going to use my good friend, nope, not that one. I'm going to use my good friend, the table of values, and I'm going to go ahead and plug in some points. I already know that the vertex is on 3, so I don't need to use that point. Instead, I'm going to go ahead and go this way and see what's down here. So I'll go ahead and try 4 and 5 and 6, and we'll see what happens. Okay, so if I put a 4 in here, 4 squared is 16. That's a negative 32. Negative 32 plus 48. Let's write this down. Negative 32 plus 48. And then we'll go ahead and do minus 20 for the last part. So negative 32 plus 48 is going to give us a positive 16. 16 minus 20 gives us negative 4. Okay, let's put the 5 in. 5 squared is 25. 25 times negative 2 is negative 50. And then if I put the 5 here as well, that gives me a 60. And then minus 20. So negative 50 plus 60 gives me a positive 10. 10 minus 20 is negative 10. So I can see at this point, if I put it in the 6, this is getting smaller. The 6 is going to fall off the graph, so I'm not actually going to do that, which is fine, because I'm going to get 4 points based off of this, which is plenty. So 4, negative 4 is going to be here. And then 5, negative 10 is going to be here. Remember, this dotted line acts like a mirror, so I can go ahead and plot it. This point, its partner on the other side, it's 1 away from the mirror, which means it's 1 away here. This is 2 away from the mirror, 1, 2, so I go 1, 2. Okay, so that is enough points for me to go ahead and draw my parabola. We're going to try to do this with a mouse. Yours is going to look better than mine. Oh my goodness. Okay, you get the idea. We're going to pretend that looks better than it does. But you remember what a parabola should look like. That should look like a smooth U, okay, upside down U. All right, so that's how you do it. So step 1, you find the axis of symmetry using this formula right here. Step 2, take that number, plug it back in, and get the y value. You put that point right there. That's going to be your vertex. It might open up or it might open down, but that helps you determine what other points to put in. And so we're aiming to find at least 5 points total. 1 is your vertex. You really only need 2 more and their partners. Okay, so what I would like you to do is go ahead and finish these problems here, and then when you're done with this page, you'll notice there's a couple of additional circle practice problems. So we did that yesterday. You're gonna go ahead and do that. So when you're done, you should be really refreshed on graphing linear equations, absolute value equations, quadratic, and also circles, because that's going to help prepare you for the project that we're going to do next. As always, if you have any questions, feel free to reach out to me. Hope you guys are doing well. I miss you, and I will talk to you soon.